This time we'll pick up the PowerPoint design document that we started after the initial playthrough. We've already logically segmented the game into parts, which will become rooms in GameMaker. We'll then design and implement 3 objects that control basic features used in all the rooms in the game. Let's open our PowerPoint document and revisit the game flow diagram. Now, in the last video, I explained some of the abstractions provided by GameMaker. One of them is the idea of a room, which is basically a logical segmentation of the game world. Rooms define settings such as size, views, and objects that interact with each other in the room. A game flows from room to room. Now, I think we see that the game flow on our diagram naturally fits the idea of a room. So let's give these rooms specific names here on the diagram. Now, regardless of which room we're in, I can think of 3 different tasks that need to happen. First, we need to know the details of the current game, such as which mission the player is on. Also, we saw that the game keeps track of the number of kills a player has made so far. Both variables are closely related to loading and saving as well. Second, we should read and dispatch user input to objects listening for the input. Now, technically, GameMaker allows direct access to input by any object in the game, but I prefer to mediate the interface manually. This is a common pattern in the object-oriented world. Now, third, every room has 1 or more pieces of theme music playing. Now, as I've typed here, we'll make a persistent object for each task. GameMaker includes the idea of object persistence to allow instances to stay around after we change rooms. Normal behavior is that all object instances are destroyed between rooms. So let's specify what these objects do in more detail. As far as we've seen, the game between missions only contains a current mission and a count of the total kills. Likewise, the 10-slot save game data would only contain these 2 variables that we'd save in a file. We'll make all of this happen as part of the constructor. In GameMaker, this is called the create event. Now, the keyboard object has more moving parts. We'll initialize it with an empty stack and an empty linked list. Now, during the early part of the game loop, we'll clear the stack, check all the inputs for activity, push that activity onto the stack, and then distribute the inputs as commands to other objects in the linked list. Finally, whenever the room changes, the object list should clear itself since all the references will be destroyed. We don't see it here just yet, but when the game objects are created, part of their constructor will require that they register themselves with the keyboard object here so that they can receive commands. It's up to the listening objects to decide if the commands are interesting for them or not. Finally, the music object will be another lonely singleton. We'll initialize its only variable to 0, but we'll use it to hold a handle to the current music playing in the room. Then when the room starts, we'll start the music based on that room for now. When the room ends, we'll also end all audio. I haven't decided if we'll expand the role of this object into sounds or not. We may improve the interface for that later. That takes care of the high-level design, so let's go into GameMaker and make both the rooms and the objects. Right-click on Room and hit Create. We'll name it with the first room, that is a RM Intro. Now, the original game is 320 by 200, so let's up that by 3 times, which is 960 by 600. Now, this code button here opens up a custom code window to execute when the room is created. We'll fill this out when we work on the rooms. Note that this code block in the first room is the first possible opportunity to execute custom code. Then we'll change the background color to black. Finally, under Views, I want to make some changes to the View area. We'll enable Views. Now, views are a feature that decouples the camera with the room. Sometimes we have a large room, but we want to only see part of it. In our case, we'll just use views to automate the scaling of the original game assets, which are all drawn in 320 by 200. Basically, this is just automatically upscaling to the new window size without us having to do any extra work in code. Now let's duplicate this room 4 times and change the names. Now, if you're thinking that the mission room should be very large because the city is large, well, then you're on the right track. We'll change these parameters as we need them, but this is a good starting point. Now let's make the objects. We'll start with the current game object. Make a new create event, new code block, / at the top lets us set our header that we can see in the event window. And we'll set the variables as we discussed. Now we'll create a file handle as a local variable and open up td.sav, which doesn't exist yet. We'll take care of that in a minute. So 10 saved game slots with 2 variables each is a perfect use for a 2D array, with the game indexing the first and the variables in the second. Close all that. That's it for the game object. Let's create the keyboard object. Under the constructor, we'll make the list and the stack. It's so easy in GameMaker to create these data structures. Now, normally when you make a data structure, you should make sure that you destroy it, but since this is a persistent object, it will only be destroyed when the game ends. There shouldn't be a risk of a memory leak here. Now for the begin step. Let's get the keyboard input. First, we'll clear the input stack, which should already be clear at this point since it's fully processed every turn. There's really 2 categories of events that I want to look for on the keyboard: the active and initial pressing of keys and the act of holding down a key. These are 2 distinct events. I'll just one-line all these checks. Normally I'd consider using an enum data type or a macro as the argument to be pushed, but I'll just make it a string data type. We'll mess with flags later on when we process commands in the objects. I think the movement direction and the fire button should be okay for now. Okay, and check if the keyboard was pressed at all. Of course, this means that for every key that's pressed, at least 2 commands will be pushed on the stack, including the any case. Now we'll roll through the list of listening objects and push the commands to them. We'll let the objects themselves filter what they want. Note that the listening object should already have a stack defined, which I'll call command stack. Let's not forget that when the time comes to actually make those objects. Finally, we'll clear the target list when the room ends. Make sure it's persistent. Now the music object is simple. 1 variable to hold the current music, which is 0. Now we'll set the music when the room starts. I'll reuse the same music for the briefing and debriefing, I suppose. Stop all music when the room ends. Now we're not quite done. We have 2 loose ends. First, we need to get a blank save game file for the game to open or it'll throw an error. Then we have to actually instantiate these objects in the game. Right now they're just definitions. They don't exist in the game until we create them in a room. So since we defined that save file as a text file with 20 variables, each on its own line, we'll need to make sure that our file includes both a 0 in each line, along with the appropriate carriage return and line feed. And the easiest way to do that is to just open it in Notepad and make a list of 20 zeros. Save the file, and then drag it into the included files section of GameMaker. Okay, the final problem is to initialize the game. Right now, all we need are these objects to appear in the first room, but I'm sure we'll be adding other things to the game initialization process. So let's create a script that's easy to access. Create a new script, we'll call it initGame. Then we'll just create the 3 objects at the point of origin in the room, which is the upper left. These objects don't physically interact with the world, so the positions don't really matter. Now let's add the script to the first room, and that should be it for now. Alright, the build didn't fail, and the objects didn't throw an exception. Now, unfortunately, there's nothing to see because we haven't created anything that displays on the screen, but we can hear the music for the first room being played in the background. We've now created the logical frame for the game, including all 5 rooms and the global level objects that are always in use. The next dozen videos will fill out each of these rooms by alternating through the design and implementations in 2 separate videos.